Hi folks, it's Mr. Defy once again. I'm back for another video. This one is about completing a function table. And a function table really is just an expanded version of the more traditional input-output table. And let me go ahead and get right into a small intro about that. Now, a traditional XY table or input-output table looks kind of like this, where you have your inputs on the left, outputs on the right. And on that note, other words for X and Y would be input, domain, and independent variables. Whereas on the right side, other ways that we can express Y would be output, as I mentioned earlier, range, and dependent variables. And all these are, to each other, are opposites. They are opposites of one another, which is the foundation of all math, is the law of opposites. So something good to know and remember as we're going into it. Now, the difference between the more traditional table and what I'm going to show you is, as you can see, this traditional table is very, very narrow. And it's good for certain things if you want to do a quick graph. But when you want to evaluate and get numbers and have more work involved, it probably would be better for you to take that more traditional table and just expand it outwards, sideways. And so that's what I want to show you today with a couple of examples. Here we have a function, f of x is equal to 3x squared plus 5. And my table, rather than having only an input and output, has both of those things, but the input and output side have been sort of pushed away from each other to make space for this function to fit inside, right here. Okay, and what that allows us to do is take our input numbers and do all the work here under that function in that big space, and then transfer the answer over to the right side. Now, if you're not given numbers to work with, then you can make your own. And so I'm going to go ahead and make my own. -1 and +5. Completely random numbers I just chose a moment ago. And this is the way they work. So if our inputs, which are another way of saying x, starts with the number -1, all I need to do is take this -1 and drop it in there, and drop it in there. Okay? It's substitution, the art of replacement. And so this is what I get. I get f of -1. In other words, the function using an input of -1 will give me an expression also using that -1. And all I have to do is use my skills of the order of operations to break this down. So this would be f of -1 is equal to 3 times. And this -1 to the second power here, as a side step, this doesn't mean -1 times 2. No. It means -1 times -1. It means that you have two -1s. And what you get is a +1. So now I have f of -1 is equal to 3 plus 5, which now gives me an 8. And what this means is that when I use this -1 as an input number with this function, which is up there, my result is an 8. Okay, so that 8 now goes all the way in there. And the reason is because my y's represent my outputs. My outputs are what the function puts out after working with the input, the numbers that I put in. And so now as an ordered pair, I have -1, 8. Remember that ordered pairs involve taking the inputs and putting them right there, and taking the outputs and putting them right there. Okay, that's all I've done. And that's a nice way to summarize everything I've done in this first row. My input, my output. That's a conclusion to what I've done. And now I'll do the same thing again using a 5 as my new input. Same function, different number. So this is equals, and I'll move this up here. Zoom in a bit. This is 3 multiplied by 5 to the second power plus 5. And so what I get is f of 5 is equal to 3 times And once again, this is not 5 times 2, it's actually 5 times 5, which gives me 25 plus 5. Okay, 3 times 25, when you have 3/4, you have 75 plus 5. And ultimately, what I get is 80. So this 80 goes, once again, into my output, my y, my f of x, like that. And as a summary, an input of 5 with this function will give you always an output of 80. And that's all there is to it. Now, if we don't have to graph, then we're done. This is all we have to do. Why do this if you're not going to graph, you might be asking? Well, sometimes we don't need to graph. Sometimes the purpose of doing a table like this is we are facing a word question or a scenario, and we need to know a quick summary of what's going on. And so it gives us information about the story, which we can then use to do things like make a prediction. So if I'm hiking at a certain speed, I can figure out where I'm going to be before I even get there, and so on and so on. So I can plan, like how many bottles of water to take, or how much snacks I need to pack in my backpack, things like that. Anyway, let's go to our second example. And in example 2, we have, ta-da, a coordinate plane. We're going to graph our results this time. And notice on our coordinate plane, first of all, we only go 10 spaces out in either direction. And secondly, we have two names here, an x-axis and a y-axis. X and y. Forget the word axis for now. X and y. Where have we seen that before? Oh, yeah, that's right. X and y. Inputs, outputs, domain, range, independent, dependent. That's where we've seen it before, okay? Now we're going to apply it to a graph. Let's see what we get. Our function, first of all, is m of h equals h squared minus 4. So no matter what the function looks like, you can always construct a function table from it. And so mine will look like this. Where's that color I was using before? There you are. So mine will look like the following. It will be input, which in this case is my h. Okay, it's always, your input's always this right here. That's always your input. So if you don't know what letter do I start with, that's how you know. Just look over there, it will tell you. And you put that right over here. Followed by the function itself, which is m of h is equal to h squared minus 4, followed by the result of that, which I'm going to represent this time as m of h, right? So that will give you your output. And then finally, the ordered pair. Ordered pairs. And then you just cut it up here, 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 one all the way across. And I'm going to make more rows this time for reasons that you will see. 2, 3, 4. Okay, and again, no matter how big the table is, how many rows there are, if you are given input numbers to work with, simple. Just use those numbers and plug them in. They would go all along your table. They would go here, 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 whatever your input numbers are. But if you're not given input numbers to work with, then you have freedom to choose your own, whatever you want them to be. Your choice. In this case, I will choose -1, 0, +1, and +2. All right, let's do this thing. So just like before, where your inputs go into the function, you evaluate them, you get your output, you summarize it with an ordered pair, just like all that, we will do the same thing, but with these numbers and this function. Watch. And I'm going to leave out m of -1 so that I have enough room to do my math. So this will be -1 squared minus 4. All right. Now, again, this is not -1 times 2. It's -1 times -1, which is +1. So now I have 1 minus 4. And that gives me a -3. And guess where that goes? That's right. That goes right in there. So now I have a -3 in my output spot. I better write that in. Output. This is my input. And as a summary, or my ordered pair, I have -1. When I use -1 with this function, the result was I got a -3. I'll do the same thing with the 0. This will be 0 squared minus 4. 0 to the power of 2 or 0 squared is just 0. Whenever zeros are involved, life becomes so much easier because that just disappears and I get -4, which then goes, like before, over there. So I have -4 as my output and 0, -4 is my ordered pair. With the 1, it's 1 squared minus 4. This becomes 1 times 1, which is 1. 1 minus 4 is -3. That goes here. Wait, hang on. I have two -3s for an output. Oh, let me see. My inputs, however, are -1 and +1. Curious. I wonder what that means. Well, we'll find out when we get to the graph. So anyway, moving on. This is 1, -3. And finally, my last row would be 2 squared minus 4. 2 times 2 is 4. Again, be careful here. This is not, it's not this 2 times that 2. It's this 2 times itself, which makes a 4. Minus 4 equals nothing, 0. That goes here. And my ordered pair is 2, 0. All right, so we have our table all filled out. Now we can come over here and I'm going to expand this a bit so we can see better. And we can transfer our points directly into this graph. So here we go. It's going to be -1, -3. Now, to plot points, remember one thing. Always start at the origin, which is right over here. It's the center of the graph, okay? It's like your reset button. Every time you put a point anywhere, you will always reset and come back to the origin. That's the center. So from here, -1, -3 is -1, -3. That's my point, okay? My second one is 0, -4. So 0 means I stay. -4 means I just slide right down. There's my second one. 1, -3. 1 and -3 is right over here. Oh, I see now. These are opposites of each other. Look at that. This is -1, -3. That's 1, -3. Now I understand. 2, 0 is right over here. And I'm guessing that if these are opposites of each other, this probably has an opposite also. So you know what? I'm going to take a chance and put an opposite point right there. And it turns out actually that that's the correct thinking. It's okay to do that. This will create a shape that has a special name. And the name of the shape is a parabola, which actually continues forever. Now this is, technically this is an Algebra 1b graph and an Algebra 1b function, but it doesn't matter. The point of it is to show you that with a function and a table, you can create a graph which represents the data, the information contained in that table. You can see it visually. This is what it looks like. And whatever whatever in the world this means, doesn't matter for now. All that's important is for you to understand that from a function, you can create a table. From a table, you can create a graph. And if you're dealing with a word scenario, then we can look at everything together, function, table, data, and graph, and make sense of the scenario and all these things here, okay? But for now, we don't have a word scenario. We just have this. So I hope you found this useful. Make sure to watch it as many times as you like until it makes really good sense and it's clear in your mind how to break things down. I would appreciate any comments, opinions, suggestions that you may have, because I'm always looking for ways to improve my videos. So thanks for watching, and you take care. See you next time. Bye-bye.